Welcome to Impetus Podcast. Today, we bring you a brand new episode of Expert Speak, where our panelists share powerful insights on everything cloud, data, analytics, and AI.
Hi, I'm Larry Pearson, Vice President and Client Partner at Impetus Technologies, where we specialize in what I like to refer to as all things data. And in that capacity, we help large enterprises in their quest to be data-driven enterprises, and most importantly, to maintain what is commonly referred to as a single source of truth with regard to their operations and their decision-making. And we host these thought leadership podcasts periodically to share some of our experiences in working with large, complex enterprises on a variety of what seem to be hot topics. And the hot topic we'll be addressing today is operationalizing Kubernetes on cloud or on-prem with speed and reliability. I'm delighted to have my colleague Mustafa Badriwala with me today. Mustafa has more than 16 years of industry experience, primarily in cloud, DevOps, and containerization, and is a leader on our DevOps team in that regard with great experience in designing and operationalizing multiple cloud solutions, focusing on some of the non-functional requirements around security, performance, scalability, and elasticity. And Mustafa, welcome to our podcast.
Thanks, Larry.
To get things kicked off, I've got the first question I would like to have you share with our audience is what are the key operational challenges that enterprises face today in leveraging Kubernetes in production environments?
Sure, Larry, and that's a really a good question. First up, and Larry, Kubernetes is one of the fastest growing technology in recent times. A lot of big enterprises, small enterprises are all racing towards adopting Kubernetes. But one of the irony, as you spoke about, is that still there are a lot of operational challenges when it comes to taking Kubernetes workloads in production. Development teams have been quick to adopt Kubernetes since they can easily set up their environments locally using tools like Minikube, and they can start development. But when the question comes that how do we take these workloads into production, that's where the operation teams and the DevOps team starts facing challenges. And some of the primary concerns the teams face are that there are no tools for an end-to-end management and governance on Kubernetes. There are a lot of security limitations as well. How do we monitor large Kubernetes environment? And one of the other concern is there are a lot of options related to Kubernetes adoption. You can have Kubernetes running on premise. You can set up a Kubernetes environment on cloud using infrastructure, or a lot of cloud providers are providing platform service as well for Kubernetes. There are multiple distributions. You can go for open source. You can use enterprise distributions like OpenShift. So there are a lot of options. Teams struggle to see what is the best choice for their requirements. Setting up a Kubernetes environment, especially the production environment, is a multi-step process. Requires a lot of configurations, a lot of hardening to make an environment production grade. That's where teams struggle. There are no tools that can automate the entire process and make sure that human errors are less. In a lot of our engagements with where we have worked with large enterprises, we mostly create custom frameworks using Ansible, Terraform, and automate these setup end to end, right from procuring, creating the hardware or the infrastructure on the cloud to the installation of Kubernetes and then configuring it for high availability and all the possible security configurations.
Excellent. Great way to get our conversation kicked off. I've heard a lot about the importance of observability in a Kubernetes environment. Could you talk about that and how it can be implemented?
Sure, Larry. And Larry, you'd be very kind of interested to know that the observability phenomenon actually came since the adoption of Kubernetes. So, if we look at Kubernetes, it has a lot of components built into that. It has a very kind of open surface area. It has its own plugins, it has its platform, there is an infrastructure on which it is running, and then there are applications. So, observability refers to a holistic monitoring where you are monitoring all the components, as well as you also have capability to trace and debug problems right to the root cause. We need to build capability in our cluster so that if something goes wrong, we are able to get to the root cause, get the actual logs, events, and perform intelligent correlation across these components. For example, from a monitoring perspective, we need to know that how our clusters are performing, how many pods are running on the cluster, which pods are in dead state or in idle state. Similarly, if something goes wrong, we need to have all the logs available. So logs would come from applications that are running on top of the cluster. It would also come from internal Kubernetes events and components. In order to trace that what's going wrong, right? When a request comes to your APIs, we need to identify the source of the request, the container or the pods that are handling, and the overall request latency that is required to handle and respond to those requests. Similarly, one of the important aspect of overall observability is monitoring the events in Kubernetes. So when it is scaling up, when it is scaling down, what happens when a pod goes down. So Kubernetes provides resilience to our applications, but we need to monitor the entire life cycle of our containers. Again, industry is still trying to come up with comprehensive solutions. Lot of application performance management or APM tools that are commonly known as are trying to come up with the support for Kubernetes. At the same time, focusing on open source, we have been using tools like Prometheus, ELK, Jagger to develop custom observability platforms for monitoring some of the large Kubernetes clusters that we have been working with.
Excellent, Mustafa. And what about the different controls that are provided by Kubernetes for enterprise security? Obviously, there's a lot of focus on security today and in the enterprise world. Is there a way to automate security checks in a Kubernetes cluster?
Right. And Larry, so when we started, right, so security is one of the prime concern. And you must have heard of recently about couple of attacks on Tesla and Capital One environments. Again, you would kind of be surprised to know that these attacks actually happened from their Kubernetes clusters. So Kubernetes, since it has a very wide surface area with different components, applications, it opens quite a lot of doors for potential hackers to get into the system. We need to address these concerns when we take Kubernetes into the production environment. There are a lot of controls provided by Kubernetes, like image security. So, image, which are the primary source of running, executing your pods in the Kubernetes environment, need to make sure that images are free from vulnerabilities. We need to integrate the scanning of these images right into our deployment and build process. Then there are isolation aspects like namespace and resource isolation. Namespace refers to segregating different workloads or different environments in a single cluster. The applications running in different namespaces cannot communicate with each other. It also provides us a mechanism to distribute resources evenly or as required basis to different applications. Some of the applications that needs higher resources are more critical. We can have them in different namespaces. Similarly, there are RBAC policies, which is role-based access control, which can be configured so that different users in the cluster have specific access and permissions to execute a given set of pods. In some of our experiences, we usually create administrator users which have actual control of all the configuration changes, while the DevOps and the operations teams are mostly related to debugging any failures that happens. Similarly, since there are a lot of network components involved, we need to have appropriate SSL certificates, TLS enabled for enabling the network security. There are a lot of pod security policies in place so that you limit the interaction of your pods with external environment. This makes sure that none of the external traffic can reach directly to a pod so that it minimizes the risk of external vulnerability attacks on the application. In order to secure your credentials or information, Kubernetes provides secrets where we can store such confidential information related to configuration, access keys in the cloud, etc. Also, we have come up with a automated way to scan Kubernetes clusters periodically for security threats. We are using CIS benchmark, which is Center for Internet Security, and we have automated that benchmark execution with Jenkins. One of the benefits that we have achieved with this automation is that whenever, if any admin or any developer makes any configuration which is not compliant, we get a real-time notification. This makes sure that our clusters are hardened for security and there is no misconfiguration at any point of time.
Excellent, Mustafa. Obviously, in an enterprise scale implementation of Kubernetes or any other service, really, the different scaling options that may be available are very, very important. Could you kind of take us through the scaling options available in Kubernetes?
Sure, Larry. In fact, scaling capabilities of Kubernetes is one of the primary factors where enterprises are adopting it. It offers two levels of scaling. One is at the cluster level and other is at the application level. With cluster level scaling, we can actually horizontally scale our Kubernetes cluster. That means we can add nodes at runtime to provide more computation and memory to applications running on top of the cluster. For on-premise environments, it becomes an offline process because you need to procure the machines or the virtual machines and add it to the cluster. But in cloud environments, this can be an automated process where we can actually create an instance on demand and add it to our existing cluster. And that's what a lot of platform services like Elastic Kubernetes Service, Azure Kubernetes Service, or Google Kubernetes Engine offers out of the box. Coming to the application level scaling, as applications are running inside pods, Kubernetes provides configuration where we can define the minimum number of pods that are always running. It gives fault tolerance to the application. At the same time, we can define policies based on that our pods can auto scale up to a configured maximum capacity. These policies can either be in terms of CPU or memory utilization, as well as with recent changes and releases in Kubernetes, we can also set up policies on custom metrics related to our application. For example, if for my application the request latency is increasing, that means the current processing is not able to serve the user request within the SLA, we can have a custom metrics that will actually increase the number of pods so that I get more computation power to handle incoming client requests.
Thank you, Mustafa, for all of your valuable insights. I trust our listeners found them quite useful. If you are out there in the audience and you have any other questions, you can write to us at podcast@impetus, impetus.com, and our expert panel will respond to those. Thank you all for joining us. I look forward to having you join us again for a future podcast. And again, Mustafa, thank you for your time and your thoughts.
We hope you enjoyed today's episode. Do follow us to stay connected as we help you unravel the data, cloud, analytics, and AI puzzle. You can also look us up on LinkedIn and Twitter or visit our website, www.impetus.com. Meanwhile, we hope you take good care of yourself and stay safe during these unprecedented times. Thank you for listening, and watch this space for our next episode.